Welcome students to the online learning of South International School. This is part 9 of grade 10 science chapter number 10. So in this lecture we will be learning how to draw ray diagram in a convex lens and a concave lens. So first we will discuss what are the rules for the formation of image by lenses. Now we have already discussed there were four rules for the image formation of image by the spherical mirror. Okay, so let's see what are the changes, what are the rules in lenses. So the first rule is that in both the lenses, a ray of light passing through the optical center goes without any deviation. The first ray of light, you can see the incident ray passes from the optical center. So when it passes from the optical center, it will not it will not deviate its direction. Means दिस वॉज द फोर्थ रूल ऑफ द स्पेरिकल मिरर, है ना. सेंटर ऑफ कर्वेचर में से पास होता है तो वो सेंटर ऑफ कर्वेचर से ही वापस आता है. तो इसमें क्या है कि ऑप्टिकल सेंटर में से पास होगा तो वो डिविएट नहीं होगा, वो रे डिविएट ही नहीं होगा, वापस ही नहीं आएगा. यू कैन सी बोथ द फिगर्स, convex lens and concave lens. In both the states, when it is passing through the optical center, it is not deviate. The second rule, a ray of light parallel to the principal axis. Okay, principal axis के साथ parallel होगा तो after refraction it passes through the focus on the other side of the lens. Okay, this was the same in the mirror also. The parallel ray of light principal axis के साथ जो parallel होता है वो focus में जाके focus से pass होता है. So here also it is the same thing in both the mirror, in both the lenses. Third one, a ray of light passing through the focus after refraction. Okay, focus में से जो जाता है वो refraction के बाद principal axis के साथ parallel हो जाता है, the opposite of second one. So here we don't have the pole one because we are not considering a pole, and it is the angle of incidence is not equal to angle of reflection. Reflection तो हो ही नहीं रहा है. So that's why here the fourth condition is not applicable. Now let's see the image formation. Now this is a table which shows the nature, position and size of the image formed by a convex lens. Okay, उसमें कॉन्केव मिरर में इतने सारे कंडीशंस थे, 6 फिगर्स हमने किए. वी हैव डन 6 रे डायग्राम्स इन द कॉन्केव मिरर. सो हियर इट इज़ इन convex lens. First is position of the object at infinity. The image will be formed at focus. The image will be diminished in point size. Nature will be real and inverted. In all the cases, the nature of the image is real and inverted. But last one, that is it is virtual and erect because it is enlarged. And when it is beyond 2f1, okay, beyond 2f1 means it is away from 2f1. 2f1 के पास होगा. So the image will be formed between f2 and 2f2. It will be diminished, real and inverted. When the object is kept at 2f1, it will be at 2f2. It will be the same size of the object and real and inverted. Okay, देखो पहले हमको धुंधला धुंधला दिखता है, then we get the same size of the object when it is at the focus, that is 2f1, image is at 2f2, the same size of the object. Then we can see the image gets enlarged between f1 and 2f1. The image will be beyond 2f2 and it will be enlarged. At focus f1, it is at infinity, image formed is at infinity, and it will be very enlarged. When the object is at focus f1 and optical center O, between O and f1, it will be on the same side of the lens as an object. So when the image is formed at the same side, it will be virtual and erect, and the image will be enlarged. Now let's see the ray diagrams of the same. In the first figure, in the first one, when the object is at infinity, and we cannot see the object when the object is at infinity. So here also we will consider only two rays. Okay, so in the first A1, the first condition, when the object is at infinity, the position is at focus, all the ray of light converge and meet at the focus. So it is at focus f2. The image will be highly diminished, point size, and it is real and inverted. Okay, in the second figure, that is when the object is beyond 2f1. When the object is kept at 2f1, AB is the object. The first ray of light is parallel to the principal axis. It will pass through the focus, that is f2. When the ray of light is passing through optical center, it will not deviate. So we can consider meeting point at f2 and the ray passing through optical center. They both meet at a point between f2 and 2f2, that is a dash and b dash. Okay, we can say that between f2 and the center of curvature, so that is point a dash and b dash, the size of the image is diminished and it is real and inverted. Yes, it is the inverted figure. Okay, now here we can see that the distance from O to 2f1 is the object distance, and O to a dash b dash is the object image distance, and the u is the object distance, and distance from O to f2 is the focal length. Third condition was when the object is at 2f1. When the object is at 2f1, the first ray of light again will pass through f2. The second ray of light again pass from optical center, will not deviate. So where the both of them are meeting, it will be at 2f2. When the object is at 2f1, it will the image formed is at 2f2. So it will be same size of the object. Again, it will be real and inverted. Then next, when the object is at f1 and 2f1, the first ray of light parallel to the principal axis passes through f2. The second ray of light from optical center, it will not deviate. Where this both ray of light are meeting, it is known as a dash and b dash, and it will be beyond 2f2. Next is the fourth one, when the object is at f1. Okay, AB is at f1, object is AB, it is at f1. First ray of light is passing through the parallel to the principal axis, passes through f2. The second ray passes from optical center, it will not deviate, and there is no meeting point. Okay, we cannot see a meeting point, that means it is at infinity. The image form will be at infinity. It will be large or highly enlarged, and it is again real and inverted because it is forming in the lower direction. Now next is when the last figure, when the object is at focus f1 and the optical center O. When it is at between f1 and O, first ray of light, see the figure AB, see the term mention AB. The ray of light from A parallel to the principal axis passes through f2, and again from optical center there is no meeting point, but this ray of light tends to meet. The imaginary line meets at the point A dash and B dash. So this is virtual and erect image. Now from this figure you can say that the sign conversion of spherical mirror is same as the spherical lens, but only thing is it is not passing through P. We have to consider it from the optical center. The center is the optical center. The center is not the pole. Only that is a different condition. Whatever Cartesian coordinate we are making, it will be from O. It will not be from P. P is not the center. Here O is the center. Remaining all distance on the left side is negative. Distance on the right side is positive. Okay. And the above one is positive, below one is negative. Y-axis is positive, below y-axis is negative, and the left side is negative. X-axis minus the second quadrant. Okay, it will be minus, and the another quadrant will be positive. That is from O to F2 is positive, O to F1 is negative. Now let's see the image formation in a concave lens. So again here we have only two position of the object at infinity and between optical center and the lens, infinity and the optical center. In the first one, when the object is at infinity, the position of the image will be f1, and when the size will be diminished, and nature of image will be virtual and erect. In both the cases, the nature of image is virtual and erect. When the position of the object is between infinity and optical center, the position of the image will be between f1 and optical center. The size of the image is diminished, and the nature of image will be virtual and erect. Now let's see the ray diagram. figure 10.17, and the object is at infinity. Okay, from infinity beyond to f1, the object is kept beyond to f1, that we cannot say where it is. The first ray of light is parallel, the second ray of light is also parallel. They tend to meet. The imaginary lines are meeting at f1. As the imaginary lines are meeting, the nature of the image will be virtual and erect, and it is meeting at f1, and the ray of light is diverging and it is meeting at f1, so the size of the image is highly diminished and point sized. In the second condition, when the object is kept between infinity and the optical center, okay, between infinity and optical center, we can say between f1 and o, the ray of light parallel to the principal axis tend to meet at f1, and the ray of light that is passing from optical center, it will not deviate. So when we take the meeting point, the intersection point is at a dash and b dash, we get the intersection point as a dash and b dash, that is the image, the position of the image. From the position of the image, we can say that we are getting a virtual and erect image, and it is diminished. So this is the image formation in a concave lens and a convex lens.